Okay, so today we are going to talk about capacity. And hopefully you can hear me okay. I've got a neighbor mowing the lawn outside, so if you hear some background noise, please try to ignore it and direct your attention back to capacity. Now, capacity I actually didn't talk about too much in the introductory video, and I really should have because it's quite an important unit of measurement that we talk about. And it's related very closely to volume. Now, we talked about volume in previous videos, obviously, but we essentially link capacity to it. And once we have volume, capacity deals with the amount of liquid in a particular volume. And we humans, we like to have things in certain compartments. So we talk about area and volume in terms of length and that type of measurement. But we talk about time here. We talk about weight there, and capacity has its own thing because it deals with a very unique um, concept, which is liquid put in some type of volume. So I'm going to draw here a type of water tank. So this could be a fish tank or something else. Use your imagination. But we have this thing here, and I'm going to draw this in 3D. Just try to excuse my bad drawing here, but we have a 3D tank. And actually, it's a bit hard to see with this one. I'm just going to draw it normally so I can actually show the liquid within it. So say I had my rectangular prism here, my fish tank type of thing, and I filled it all the way to the top with water. There's nowhere in this that water has not touched. I filled it to the absolute brim, and this is all water in here. Cool. So my my volume within this, I'm going to give us a couple of numbers. So I have 10 centimeters. I have, I'm going to have 10 centimeters in width. I'm going to have 5 centimeters in height, and I'm going to have 4 centimeters in depth or breadth, whichever one you'd prefer to use. So to find capacity, we first need to find volume. And I'm going to relate these two in a minute because capacity, like all other measurements, are a human invention. And we've given it some value and we've linked it to volume in our own way. So first, I'm just going to calculate the volume of our prism here. So this may be a bit of revision for you, obviously, but to find volume, we're just going to multiply each of our dimensions here. So we have our 5 centimeters multiplied by our 10 centimeters multiplied by 4 centimeters. And we are going to end up with a volume of 200 centimeters cubed here. Now, all capacity is a relation to a volume. And the only kind of formula or equivalence, if you want to call it, I'm going to write here, is how we relate capacity to volume. The main crux of this is that 1 milliliter, which is a measure of capacity, equals to 1 centimeter cubed. So we are essentially relating capacity, some measure of a liquid within some volume, to the respective volume of the object the liquid is contained in. Hopefully that makes sense. But this is our kind of relation here. I'm going to put a little box around it because this is the most important one you really need to know, because everything else stems from this. This relationship links capacity to volume. So my water is filled all the way to the top here. So our entire volume is composed of liquid. So from this, we can therefore say that our capacity equals to 200 milliliters. It's essentially as simple as that. And a couple of unit conversions that we do for capacity, as I've talked about before, we've come up with these units for different scales. So if I wanted something to measure something really small, I would use milliliters. Maybe the amount of liquid in a cup. If I wanted to talk about a swimming pool or a massive submarine-sized thing filled with water, I would talk about liters or kiloliters, or even bigger or smaller. But the most common ones you'll encounter, I'm going to write a couple of these relations here. So we know that there are 1,000 milliliters in 1 liter. Also, there are 1,000 liters in a kiloliter. That's about as far as I'm going to go here. We've defined capacity as a relationship to volume in which 1 centimeter cubed of volume equates to 1 milliliter. And with our units for capacity, we know that they hold these relationships in a very similar way to our other units of measurement we've talked about. These milli, centi, kilo, we see the same ones in length as well as weight too. So that's a little introduction into capacity. And a lot of the questions we'll deal with end up in this similar format, where we need the volume to be able to tell us about the capacity, and vice versa. So thanks for joining me here, and I'll see you in the next one.